In this lesson, we'll take a look at the fill down method on a range object. The fill down method populates a formula or a value downwards based on a given cell value. We use this feature a lot when we're working with Excel, and we can emulate it using VBA. I'll begin here in my sheet by populating column A with a list of numbers. Let's just do 1, 2, 3, 4, 5. And let's say I wanted to take the square of each number in column B. There's a built-in function in Excel called power. Power accepts two arguments. The first is the actual number. We're just going to reference cell A1. And the second is the power that we want to raise each number to. So if I want the square of the given number, the power is 2. So this is going to be 1 squared. And we can now replicate this formula downwards in one of two ways. The first is to click the bottom right corner and simply drag it all the way to the bottom. As soon as we let go, Excel is going to replicate the power formula for every cell below. The better way to do it, I'm just going to remove my work, is to click into the main cell, hover your mouse over the bottom right corner. You're going to see this little black cursor pop up, and if you double click that, it's going to extend the formula to the next blank cell. So the exact same functionality, but if you have a really long list of records, like 1,000 rows, and you don't want to drag down, this is a much more efficient way to accomplish the same thing. But this is called the fill down operation because we're taking a value or a formula, the one that we have in cell B1, and we're filling it down to the remaining cells in that same column, right? We're replicating the same functionality as we have in the current cell. And VBA can do that exact same thing for us. So what I'm going to do here is remove all this content below. We still need an actual cell with a formula. So if you need to code this from scratch in VBA, you're going to need to use something like the formula R1C1 property on a range in order to target the very top cell and actually manually set the formula that you want to use, because we need that as a basis in order to actually perform the filling down process. Now let's go ahead and actually write this formula. So in my VB editor, I'll create a procedure called fill cells. And here's what I'm going to do. It's a one-line procedure, pretty simple. We want to target a range, and here's the tricky part. We don't just want to target the blank cells, we want to target the blank cells and the cell that includes the formula. So that's cell B1 for me. So I want to begin with cell B1 and go all the way to B5. So once again, I'm starting with the cell that actually has the valid formula, and then I'm ending at the cell that represents the last cell that I want to paste the formula to, or the last cell that I want to fill down the formula to. Then once I have that, the only thing I need to do is call the fill down method, capital F, capital D, fill down. Take a look on the right, or rather the left side when I execute. There we go. The exact same thing has happened. We have taken the formula in cell B1 and filled it down all the way till cell B5. Let's take a look at another example here on sheet 2. I'll begin here by writing a list of first names and last names. I have a little bit of formatting left over here. So I have a list of first name and last names. Let's just make this US presidents. So I'll fill this in with George Washington, John Adams. Let's do Thomas Jefferson. And let's say I want to have a third column that represents the full name. So how can I create this operation? The first step, of course, is to always write the actual formula that you want to use in the top cell. So there is a concatenate formula in Excel, or rather a concat one. They look pretty identical to me. I think there might be some small differences between them. But concat accepts a list of arguments, and it just concatenates all of them or adds those strings together as one. So we want to target the first name column, or the value in cell A2. We then want to actually add a space to make sure that those two strings are not kind of clumped together. Then we want to actually add the value in cell B2, and we're going to get the full name of the president. Now, of course, if we want to copy this formula down, if we want to fill it down, again, it's simply a matter of double-clicking in the Excel interface. But what if we want to emulate this functionality in VBA? Well, what we can do here is practice our coding. So once again, I'm going to create a new procedure. I'm going to call it populate presidents, just so we have more practice with the syntax. Once again, we use range. We target the range that we want to work with, and we have to include the cell that actually includes the formula. So that's cell C2. We then specify the cell we want to go up to. That's going to be cell C4. Finally, once that's complete, we call the fill down method, execute that. Same thing, the formula has been filled down to the specified cell. All right, so that's how we use the fill down method. It works the exact same way as it does in the Excel interface. This is a very, very common feature among users, so it's really great when it's used right here. Instead of, for example, iterating with a for loop and manually calculating each cell, what you can do is just write a formula in the top cell of a column and then use this thing, and that way the process should be a little bit quicker because it just replicates that logic for every cell. You don't have to repeat that looping and going through everything, every record one by one. So it's a really great shortcut. That's all there is to cover here. I'll see you in the next lesson. In this lesson, we'll take a look at the replace method on a range object. The replace method works very similarly to how find and replace works in the main Excel interface. We first identify a range to search in, we then identify what we're looking for, and then we tell VBA what to replace it with if it's able to find something within the range. So just like find and replace works in our main Excel window. So let's demonstrate this with VBA code. I'll begin by populating a list of values in column A. So let's just do a bunch of numeric values here. Let's pretend that these are the rows of some kind of report that we're getting. And let's say that some of these rows have blank values in them. So I'm just going to delete some of these numbers randomly. It doesn't really matter which ones we target. So let's imagine this is our report. And let's say what we want to do is target that range of cells from A1 to A12 and replace any blank cells with the value missing. How can we accomplish this? Here in my VBA editor, what I can do is create a procedure. I'll call it replace blanks. I first need to specify the range in which I'm searching. So let's begin with the range keyword. We're going to be targeting cells A1 through A12. So we're selecting that entire box right here. Then we want to invoke the replace method on the range object. The replace method, as we can see here, expects two arguments. What and replacement are the names of our parameters. What represents what it is that we're searching for, and that can be anything from a string to a number, whatever we want to specify to look for in that range. And then the replacement argument specifies what we want to replace any matches with. So whenever we find something that we specify with what, that's what we're going to be replacing with whatever we put for replacement. So let's begin here by typing the what parameter. This is what I'm looking for. I'm looking for an empty cell, which can be very easily represented with an empty string, just two double quotes with nothing between them. I then want to put a comma to move on to the next parameter. The next parameter I have right here is going to be replacement. Once again, colon equals, and this is what I want to replace that with. So what do I want to replace any empty cell with in this case? Let's replace it with the keyword missing. So missing in double quotes, just like that. And when I execute this with F5, we can see that the blank cells have been replaced with the keyword missing. Let's go ahead and take a look at yet another example of this method. Let's say I now want to replace the keyword missing with the phrase not found. Again, what I can modify here is the what parameter. This is what we're searching for in order to replace. I want to search for the keyword missing. And what do I want to replace it with? I want to replace it with the string of not found. And again, this replacement can be anything. It doesn't have to be a string. It can be a number. It can be whatever you want. So let's execute this, and we should see the missings convert to not founds. There we go. To finish off, I just want to show you how flexible these parameters are. As I mentioned, they don't need to necessarily take strings. They can take other data types like numbers or integers. So for example, let's say I wanted to target all occurrences of 2 in this spreadsheet. In fact, let me add a couple instances here just so we can verify that this works. I'm going to put a 2 here and a 2 right here below. What I can do here is replace this what. Let me just click out of here. Let me replace this what with the number 2 rather than the string 2. It's going to find all occurrences of the number 2. And what do I want to replace it with? Let's replace it with some kind of other number. So let's replace it with something like 20. So I've replaced my string arguments with numeric arguments. So we're going to search for all occurrences of 2 and replace it with 20. This should occur 3 times. So let's execute with F5, and there we go. 2 has been converted to 20. And this 2 right here has also been converted to 20, and this one right here. It looks like something interesting has happened here as well in row number 12. It looks like what happened here is this used to be the number 12, and VBA identified the value 2 within the value of 12, and so it took that and concatenated on 20 where the 2 used to be. So you have to be pretty careful here whenever you're doing something like this. But it will replace all occurrences of the number 2 anywhere that's able to find it. So in theory, if I run this again, we have a 20 right here, and because it has a 2, this should be replaced by another 20, bringing this to 200. So let's take a look at what happens when I execute this again. Exactly. So it's going to look for any occurrence of the number 2, even if it's a number rather than a string, and it's going to replace it with the replacement, which is 20. So you have to be a little bit careful here. This was a bit surprising even to me. But that's the replace method on a range object. Expects 2 arguments or 2 parameters called what and replacement. What is what we're searching for. Replacement is what we want to replace it with. In this lesson, we'll take a look at the text to columns method on a range object. This is the exact same functionality that we have available to us in Excel right here under data. This text to columns feature, one of the most popular features in Excel. Now, if you're unfamiliar with text to columns, what it does is it takes a single string or a single cell, and then it separates it into multiple strings based on the presence or occurrence of what we call a delimiter. And a delimiter is just a special character. So let me go ahead and show this in practice, and then we can sort of walk through what it is that we're going to be doing with our code. So I'm just going to put a bunch of names here, 4 names on 4 different rows here, and it's going to be first name, comma, last name, comma, age. So John, comma, Smith, comma, 35. This is very similar to how we might receive data if we have something like a CSV file, a comma separated values file. Let's say here I have a second name like Christy, comma, Johnson, and her age is 48. Brian, comma, Carter, 22, and Dustin, comma, Lance, 15. So this is very similar to how we might get data in a CSV file, let's say from something like a website server. And what the text to columns feature in Excel allows us to do is to say these different values are delimited or separated by the presence of a comma. So what we ultimately want to do is to separate all of these values wherever we see a comma occur. So our ultimate end goal is a result that looks like this. John in one cell, then Smith, then 35, and repeat that whole process for every cell. Just separate by a comma into multiple cells compared to our original one. So how can we execute this with VBA? Well, let me go ahead and remove this code. I'll define a procedure here. I'm going to call it separate text. The first thing I'm going to do, of course, is to target the actual range that I want to perform the operation on. So we're going to target range A1 through A4. The method itself is called text to columns. Both of the T's and the C in columns are capitalized. Let's take a look at some of the parameters we have here because there are a lot. The most important one here is the first one, which is destination, which is going to represent the first cell that we're going to paste the first value to. Text to columns is going to create multiple cells of data, right? Because wherever we have a comma, we're going to create a split. We need 3 total cells here, one for John, one for Smith, and one for 35. The destination here represents the top cell where we're going to start placing the results in. So in this case, let's say we want to start putting our stuff in cell C1, then we're going to put C1 as the top, as the result or the argument for this destination parameter. So we're going to do destination. And what we actually have to give it is a valid range object, not just a string of C1, but a range of C1. So that's where it knows where it's going to paste the results. What I'm going to do here is just put a comma and an underscore. That allows us to break up our code into multiple lines. Let's take a look at some of the other parameters here if we can. Let me see if I can bring them up. There we go. So what we can actually see here is there's a wide variety of parameters here like tab, semicolon, comma, space, etc. And these are all parameters that expect Boolean arguments. Essentially, we need to designate something as the delimiter, as the special character or symbol that VBA is going to use to split these characters by. And all we need to do is pick one. So in this case, we do have here, right here, a comma parameter that is just like tab or semicolon or anything else. We just have to pick out the right one and give it a Boolean argument of true. So what I'm going to do here is I'm going to do comma, colon equals true. So with this syntax, we're both identifying the comma and we're saying that that's the one that we want to use as the delimiter. And that should do it. We're going to target cells A1 through A4. We're going to separate the text within them by a comma, and the results we're going to start pasting in cell C1. So let's see what happens when I execute this. There we go. So John, Smith, and 35 have been moved right here to C, D, and E. Notice that cell C1 is where the beginning of the paste started, and the same operation has occurred for everything right here in our original cells. Let's take a look at another example with another delimiter. So what I'm going to do here is just copy this original example, copy it down here to cell A6, and this time instead of separating everything by a comma, I'm just going to separate everything by a space. There might be an easier way to do this, of course, with something like find and replace or even the replace method that we talked about, but just for the sake of simplicity, I'm going to go through manually and just replace all of these commas with spaces. Right, and our syntax here for our method is going to be very similar. We're just going to need to replace that comma delimiter with something else. So let me go ahead here and just need to click out of here. Let me go back to my code. I'm going to comment out my original code because I don't want it to run accidentally. And this time we want to target a different range. So once again, range. What are we targeting? We're targeting cells A6 through A9. Close the double quotes, close the parentheses. We're going to call the text to columns method. First parameter we want to give is destination. This is going to expect a range object. This is where we're going to be pasting it. Again, this represents the top left cell of where we want to start the paste operation. So this time we want to start in cell C6. That's to right of John Smith. So let's put cell C6 here. Once again, let's put a comma and an underscore. This is just so I can break this up into multiple lines. If you can fit everything on one screen or one line, by all means, you can just continue typing without placing the underscore, or rather the underscore, that's what it is. All right, so next up, we see some additional parameters here. This time, we don't want to target the comma parameter. We want to target the space parameter because that's the delimiter. That's the special character that symbolizes a break in our string. That's where we want to break things up. So space colon equals true. Again, space, comma, semicolon, whatever delimiter we choose, there's going to be a parameter for it, and we just have to give it a Boolean argument of true. That should do it. So now we should see the exact same result as we have here, but this time we're going to split by spaces. Here we go. There we go. Exact same result. There's one more example here that I want to show you, and it's how we work with a delimiter that is not present in our list of parameter options. So let me go ahead and copy this code one more time. And imagine now that for some reason we have data where all of the values are separated by this vertical pipe symbol. On most keyboards, you can access this by just pressing Shift plus the backslash key, which is right above the Enter key on most keyboards. So we have this vertical pipe, and the list of parameters doesn't actually include this as an option. So I'm going to show you how we can create essentially a custom text-to-columns operation with our own custom delimiter. The basic syntax is going to be the same. It's still going to be the exact same method call, but it's going to be a couple different parameters that we're going to use here. So let's target our new range. Our new range is cells A1 through cells A14. Close the double quotes, close the parentheses. Let's invoke the text to columns method. Destination parameter colon equals where do we want to paste it? We want to put it in range. Let's put it in cell C11. I'm going to use the underscore to create a line break. Here we have a list of all of our available delimiters here, tab, semicolon, comma, space, but we don't have any kind of vertical pipe. So what do we do here? We actually need to use two parameters here. The first one is going to be other. We see other here in our list of parameters to the right of space. Other is going to be a parameter that expects a Boolean, and that's where we're going to tell VBA that we are expecting a delimiter that is another delimiter, something that's not currently listed in our list of parameters. So we have to give that an argument of true, but we still haven't told it what that actual delimiter is, and that's signified with the parameter called other char. Char here is short for character, so it's asking us for the other character that we would like to designate as the delimiter. So of course we need to provide this an argument. This is just going to be a string, and what I give the string is the actual delimiter, so I'm going to put the vertical pipe. So again, we need both of these parameters whenever we're doing some kind of character that's not common or that's not present here in our list of parameters. Otherwise, it's going to work the exact same way. It's going to look for the presence of this custom delimiter, split it up at that point, and then start to pasting in cell C11. So let me click out of here for now. Let me go back into here. Let's click F5. And there we go, the exact same result has occurred. We've now delimited by a custom character. And that's all there is to cover in this lesson. We talked about the text to columns method. The text to columns feature is one of my most favorite features in Excel, so it's really cool that we're able to emulate it exactly as it works on the front end in our actual VBE, Visual Basic Editor. Pretty cool, pretty powerful feature, very common when you're working with something like CSV data and you need to separate data that has commas in between. That's a very common format that files come in. Many people like CSV files because they're much more flexible compared to Excel files, which require Excel to open. CSV files can be opened by a lot more variety of programs, including spreadsheet analysis programs. So this is a very, very popular feature, and VBA can help you automate the process of splitting up your comma delimited or space delimited or tab delimited text with this text to columns method. In this short lesson, we'll take a look at the worksheet property on a range object. The worksheet property on a range returns the worksheet object to which the range belongs. It's kind of an interesting concept because throughout most of the course, we've been looking at the Excel object model from a top-down view. We've always started at the parent object and proceeded downwards, kind of following that nested structure until we arrived at the object that we're looking for. Well, this is one example in which we can traverse the Excel object model upwards. We can start with a range object, and then we can find out what worksheet it actually belongs to. So here I have a brand new workbook, and there's only one sheet here. It's called Sheet 1. So what I can do here is define a new procedure. I'm just going to call it discover worksheet. It's going to be very, very simple, this lesson. All I want to find out is the name of the worksheet to which a specific range belongs. So I can use message box here, and let's say I want to target a random range like C5. Again, this is going to target the active workbook and the active sheet, but right now we're only targeting the range. So let's say we don't know the name of our worksheet. Well, what I can do is target the worksheet property, and what this is actually going to return to us right now is a worksheet object. And remember, we can't just message box out a worksheet object because it's an entire custom data structure. We need to actually access one of its properties in order so that we have some kind of string to actually output with message box. So now we've proceeded upwards. We've began with the range and we've gone one step up to the worksheet that contains it. On every worksheet object, we have a name property, and this will tell us the name of the worksheet, which should be sheet 1. So when I execute this method, or this procedure rather, there we go, sheet 1. That's all there is to cover in this lesson. I just wanted to show you a different way of thinking about the Excel object model. We know that we can proceed downwards the Excel object model, but as it turns out, we can also proceed upwards in some circumstances. We can access certain properties that will allow us to find out where an object is nested. Just like in this scenario, we were able to use the worksheet property to find the worksheet object under which the current range is nested. In this lesson, we'll take a look at the sort method on a range object, which allows us to sort a range, either alphabetically or numerically, either from lowest to highest or highest to lowest, or alphabetically or reverse alphabetically. Any options that we have in the Excel interface that allow us to sort, we can replicate using VBA. Let's take a look. The first thing I want to do here is to set up our data set. We're going to have a name column and an age column, just so that we have a collection of strings and a collection of integers. So right here, I'm going to set up a column header of name. Right here, I'm going to make a column header of age. And let's just come up with a couple fake names. So let's do Jack, Bobby, Sally, let's do Billy, and then let's do another Jack, just so that we have duplicates here. And here, let's set up a couple values for ages. So let's do 15, 45, 35, 28, and let's do something like 21. Okay, so in my Visual Basic Editor, I'm going to define a new procedure. I'm going to call it sort columns. And the first thing we have to do is target the column that we want to sort. So the way we can do that very simply is just using the columns property. This is available directly off of application. Let me just double check that. Application, columns. Yep. So columns is a property off of application, and we can give it as a string a reference to a specific column. In fact, what we want to do is target all of the content within, let's say, column B. So what I can do here is do this, columns B through B. So the reason I want to introduce this syntax this way is because whenever we're going to introduce multiple column sorts, I want you to start thinking in terms of the syntax of writing the starting column, colon, the ending column. So even though we're only targeting column B this time around, I find that this syntax is the most consistent and the most flexible, and it'll kind of remind you of how you should write this syntax whenever you're referencing either one or more columns. All right, so we're targeting column B here, and I want to call the sort method on that column. So we're not getting the pop-up here, but there are a couple parameters that are available to the sort method. The first one that I want to look at is key 1. So key 1 is actually going to specify the range that we're going to be sorting within our selection. So in this case, it's a little bit confusing because our selection is the entirety of column B, but we're also going to be sorting column B. The reason that we need to write both of these things, and I'm just going to write it out right here, range is going to be B through B, is because sometimes we're going to be targeting a larger range, for example, a range of 5 different columns, but we only want to sort, let's say, by the values within one of those columns, and that's what key represents. It's what we're actually going to be sorting by. In this case, we're only looking at a single column, and we're sorting by that column, so the key parameter is essentially the same thing as the range that we're selecting. So in this case, it's the same thing. The next thing that I have available to me here, I'm just going to put a comma and then an underscore to allow ourselves a line break. We have an order 1 parameter, and this accepts a predefined constant, either Excel ascending or Excel descending, and this is going to define how that sort is going to take place. So for now, I'm going to put Excel ascending, and what this means is that everything will be sorted in ascending order, which means from the lowest to the greatest if it's a number, or alphabetically if it's a string or a bunch of characters. So here in my age column, we have the smallest value 15, and then 21 and 28, so it should be sorting in that order, from the smallest value to the greatest value. There's one more parameter that I want to add here, so I'll add another comma, And there's a parameter here called header. Header allows us to specify whether the column that we're targeting begins with a header value. In this case, we do. That value is age. That is just the information about what that column contains. We don't want age to be included in our sorting mechanism. In this case, it's not really going to be that much of a problem potentially because we're comparing numbers to strings. But if you think about something like column A where we have name, we don't want the sorting algorithm to actually think that name is one of our values and put it somewhere in between our results. We want it to recognize that it's part of the header and that VBA should ignore it when doing the sorting. So the header should stay in place and it should sort the values below the header in that column. So the way that we tell it that we do have a header in this column is by writing XL yes. Obviously, if we want to sort a column of just values, we want to tell it that it doesn't have a header. We just write XL no. All right, so this should be good. So what should happen here is only the values in column B should be sorted. So let's take a look at what happens when I execute F5. We can see that the values are now in sorted order: 15, 21, 28, 35, 45. Perfect. And of course, if I want to sort it in descending order, which means from the greatest to the lowest, I can change this from XL ascending to descending. When I execute this, we're going to get 45 at the very top and 15 at the very bottom. Now, this is, of course, just an introductory example. We can quickly see the problem with my code as it stands, which is that we've sorted the ages in column B, but we've completely ignored the relationship with the values in column A. So this is all messed up because the relationship or the connection between the name, the person, and their age has been messed up. So this obviously is just to demonstrate how we sort one column. In the next example, we're going to move on to showing how we can sort by multiple columns. So let's just pretend that these are now the proper ages for our names. So Jack is now 45, Bob is now 35, and so on. Let's just pretend that this first example was just to give you guys an explanation of what's going on. So now let's go ahead and sort more than one column at a time. We're keeping track of those values so we don't lose them like we just did. So I'm going to begin with columns one more time. This time I'm going to select the entire collection of columns that I want to target. So let's select columns A and B. So A through B. The first thing before the colon is where we're starting. The column after the colon is where we're ending. So we're targeting the entire range of columns A through B. Let's call the sort method on it. All right. Now here's where key 1 actually has an impact. When we write key 1, this is going to be the range that we actually want to sort by. But we're not going to lose track of the entire column collection. We're just specifying what we want to sort by. So for example, if I want to sort now by name alphabetically, I can say that I want to sort by the range of A through A. So what this is going to do is it's going to sort by our names, Jack, Bobby, Sally, etc., but it's not going to lose the connection with the age. So the age will be moved around whenever those names are flipped around in order to match that sorting algorithm. So now we've connected those two columns together. The relationships are not going to be lost. All right, so let's put a comma here and an underscore to break up the line. Once again, we have to put an order one parameter. This is going to specify how we actually want to sort. Let's sort our names alphabetically, which means ascending. So I'm going to do XL ascending. And once again, let's also put the header parameter. This allows us to specify that the name at the top is an actual header, so we can ignore it. It's not going to be accidentally sorted between the names. Let's execute this, see what we get. All right, so as you may recall, there was a Jack there at the very top, and they had an age of 45. So that relationship has been kept. You can see that the original values that were assigned to those names are still there. We haven't lost it. So both columns have experienced change. However, the basis for that sorting has been column A. We can see that now Billy, which is the very first alphabetical thing in sequence, is now at the very top. That age has been kept. And Sally, which is the last name alphabetically, is now at the bottom, and her age of 28 has also been retained. And we can prove this one more time. Let's just memorize this connection of Sally and 28. If we want to sort it in reverse alphabetical order, we can change this to XL descending. And when I execute this, Sally should be at the very top. There she is. And her age has also been moved up with her. So that relationship has been retained. Obviously, if we want to sort by the age column now, but keep the relationship with the names, all we have to do is change this argument to key 1. We're still targeting columns A and B, but if we want to sort by age, we're going to target range B through B here. I think that's pretty obvious. All right, now let's move on to the most advanced example, which is sorting by more than one column at a time. Let's say I want to sort first by the name and then by the age. For example, we have a Jack here, and Jack, there are two Jacks and they have different ages. So let's say I want to sort the names alphabetically, so we're going to do from the lowest to the greatest character, but the age I want to do reverse, so descending, so we're going to have the highest age to the lowest age. All right, so here's how we do that. We're going to begin by targeting the same columns as always, columns A through B. We're going to call the sort method. Our key1 parameter is going to have the same thing. We're going to have a range. Now, what do we actually want to sort by? Well, we want to sort by both. So how can we do this? Well, key1 represents the first range that we're going to sort by. That's kind of one of the most confusing parts here. Is you may have been looking at this and asking, why is there a key1? Well, because we may want to sort by more than one key sequentially. Key1 is the first thing that we want to sort by. So the first thing we want to sort by is the name. So we're going to specify range A through A. Let's put a comma here, an underscore right here. As we mentioned, we want to sort those names alphabetically, so we can do that Excel ascending. All right. And then what I want to do here is I want to now sort by the age after I've done sorting by the name. So there is predictably a key2 parameter, all right? And key2 expects an argument that is the range of the second set of values that we're going to be sorting by. So after we're done sorting by the name, we want to sort by the age, which of course is column B. All right, I'm going to put another underscore there, break up another line, and there is of course a corresponding order2 parameter that specifies how we want to sort the second key, so this time the age. How do we want to sort the age? We want to do it from the oldest age to the youngest age, so Excel descending. So now we're varying up the sorting mechanism here, or the algorithm. Finally, we do want to still provide a header, and this is going to be universal, so it's going to apply to both of our sorted columns, name and age, so we just want to give it a standard Excel yes. So before I execute, let's do a quick review here. We're going to sort the names in column A. We're going to do it in ascending order. So the names are going to be from the start of the alphabet to the end of the alphabet, alphabetical. We're then going to sort by the ages in column B. Those are going to be descending, so the greatest age to the smallest age in order, and then the header, of course, is included here. Let's execute this and see what happens. All right, so has this worked as expected? Well, we can see the names are alphabetical, but whenever we come to something that's a duplicate, for example, Jack, now VBA is able to sort as well by the age. Remember, the age is only going to be sorted by if there is a duplicate in the name, right? Because this is the first thing that it's going to be sorting by, so Billy is going to come before Bobby. But once we come to Jack, that's where it's going to dive into the order 2 in order to figure out how it's going to sort by that second key. So this Jack has an age of 45, and this Jack has an age of 15. So when it comes to sorting by age, we've specified Excel descending, greatest to lowest, so this one is going to show up first. So everything has worked as expected. If I wanted to do this in reverse, so let's say I want the names to be alphabetical, but I want the youngest age to show up first, I'd have to change this to Excel ascending. That way the numbers are going to be ascending, or smallest to greatest. So now the Jacks are still going to be in order. However, we can see that the numbers have flipped around and 15 shows up first. That's all there is to cover here in this lesson. We talked about the sort method, which is able to sort a range object by one or more columns. We first target the columns. We should use the columns property to do that. After we call the sort method, we use the key and order parameters. The key is used to actually specify what column within that range we're going to sort. Obviously, if it's only a single column, the key is going to be the exact same thing as our columns. But as we saw here, whenever we're targeting a range of more than one column, we can use key to specify which column within that range we're going to use as the basis of our sorting. The order parameter is used to specify whether it's ascending or descending, which means smallest to greatest or greatest to smallest. Whenever we have more than one column that we'd like to sort at a time, we can do key 1, etc. And finally, we have the header parameter, which is used to specify that our columns have a header, and that value should not be included whenever it's determining the basis for sorting. That's all there is to cover here. I'll see you in the next lesson. In this lesson, we're going to take a look at the font property on a range object. The font property actually returns a brand new object called font, and the font object stores properties that are related to the actual aesthetics of the font of the cell. So things like whether it's bolded or italicized or underlined, things like the font size, the actual font itself, the color of the font, anything related to the styling of the cell, that's all found in the font property on the range object. So let's take a look. Here in cell A1, I'm just going to put in some random text. I'm just going to write VBA developer. It doesn't really matter what we write. And right now, we just have the default Excel settings. So this is going to be Calibri, font size 11, nothing is bolded, italicized, or underlined. Pretty standard Excel font. So right here in my VBE, I'm going to define a procedure. Let's call it modify font. The first thing I want to do is actually target the range. So I'm going to declare a variable. I'm going to call it R, keep it short and sweet. R is going to be a range object. Whenever we assign a value to a variable that expects an object, remember we need the set keyword. So set R, let's set that equal to a range. What range do we want to target? Cell A1. Of course, if we want to target more than one cell, you're more than welcome to. Just give it that colon and specify the range of cells that you want to target. Okay, so R is our range, and on every range we have a font property. This is a completely different VBA object. It's called the font object. So if I put another dot there, here we have all of the properties that are related to that font object. Here are all the ways that we can customize what the font looks like. So here we even see things like strike through, subscript, size, tint and shade, underline. Everything that we have available here in the Excel interface is available through us here as well in the Visual Basic Editor. But again, everything here has to be done through code. It can't be done visually. All right, so let's explore some of these properties. If we want to set the boldness of the range, there is a bold property, and bold actually expects a Boolean, either true or false, because bold is not some kind of scale. It's just yes or no, true or false. So let's say we want to make this VBA developer bold. We just write true. When I execute this with F5, we can see it's become bold. Also available on the font object is an italic property. This is going to be a Boolean as well, true or false. So if we want to make it italic, we can execute like so. There it is, italicized. If I want to make it non-italic, I can turn that off with false. There it goes back to being standard. All right, so bold and italic, both are properties on the font object. Both expect Boolean values, true or false. There is also an underline property on the font object. It's a little bit more complex because it actually expects a predefined constant. So there's actually different types of underlines that are available. It's not as simple as bolding. For example, in certain forms of accounting, there is such a thing as a double underline. We have the concept of a single underline, which is just the basic way we do it. In fact, if we go here to the Excel interface, you can see that the B for bold and the I for italic is just plain buttons. But here on the underline option, we have this drop down, and there's actually a couple different options available: underline, double underline, etc. So instead of giving a Boolean here, we can actually give a predefined constant. One of them is Excel underline style single. And this is going to make a single underlined cell. So when I execute this, we can see it's been underlined right here in the cell. I'm assuming the way to make it double is just replacing the single with double. Execute that. There we go. There's now 2 lines. So because this isn't a simple choice of either yes or no, like bold or italic, we actually have a wide variety of options available here. Not really wide. There's only 2. But because there's more than one, we can no longer represent that data type as a Boolean. So we need one of the Excel predefined constants to actually set the underline qualities of the range. On a font object, we also have, of course, a size property. This is the size in pixels of the font. So predictably here, this expects a whole number, an integer, a long, if you will. So if we want to change the font size to 48, it's just the size property, give it a whole number, execute this, and there we go. We've changed the size to something much bigger. If we wanted something like much smaller, 36, execute this, same deal. We can now modify the size of our font. If we want to modify the font itself, there is a property on the font object called name. It's as simple as providing it a string this time around, because remember, a font name is just a collection of characters, so we have to represent it with a string. And then we just give it the name of the font that we want to use. So if we want to use Arial, we just type in Arial in double quotes, execute that. There it is in Arial. If we want Times New Roman, just enter that as a string, Times New Roman. There's Times New Roman. If I want my favorite font, Comic Sans MS, there we go, turns that to Comic Sans MS, okay? So one other thing that I want to show you in this lesson, which is color. Of course, color is a very important part of how a cell looks. So we have on font, we have a property called color. The interesting thing about color is that it can actually accept a wide variety of inputs. The first option that is available to us is one of Excel's predefined colors. And the way we do that is there is a VB followed by a certain color name. So very popular colors like red are predefined. This is kind of like the default Excel red. And when we execute this, we can see that it's going to resort to this standardized color. I may be mistaken, but I believe these are the colors that are predefined right here. So the standard colors like VB red are defined. I think VB blue is another option. We can give that a shot. So this is a list of just predefined Excel colors. So it's not guaranteed that your color may be represented. There may not be something like a VB gold, but whenever you need some pretty conventional, pretty common standardized Excel colors, this is one of the ways that we can provide a color to a cell. Now, this is actually a pretty limited range of color options that we have. So the more effective way to do it is to use a function here called RGB. RGB is a pretty common thing among designers, but what it stands for is red, green, blue. And essentially what this function expects is three integers, one to represent how much red content we're going to have, one to represent how much green content, and three, the third integer is how much blue content we're going to have. And the values that we can provide here is any integer between 0 and 255. So that's a total of 256 options. So that actually gives us a whole huge palette of colors, because if we have 256 options for how red something is, 256 options for how blue something is, and 256 options for how green something is, that's a total of more than 16 million possible combinations that we can choose here. So whenever you want any kind of font color, you have 16 million options to choose from, which should be more than enough to fit your designer needs. So just to show you how this works, the higher number we give, the more that color is going to be represented. So if we want something that's pure red, we can just put 255, that's the max value, and then we can leave 0 green, 0 blue. This is going to be a color that is going to be pure red. If we instead give this a 0, this is a 0 for the redness, and we give this 255, this is a color that's going to be pure green. So if I execute this, we're going to get a color that's pure green. If we put instead a 255 for the last number, which is the blue content, that's the B in RGB, this is going to be pure blue. And of course we can mix and match, so we can have something that's midway red with maybe a little bit of green with maybe a lot of blue, and we're going to get some kind of combination there that's going to look a little bit on the purple side, right? So this is how we can come up with all of these custom colors. We have more than 16 million combinations. Many times, if you're working with something like hexadecimal codes, which is more common in HTML, there's many different online converters where you can pick a color or convert a hexadecimal number to an RGB equivalent. It's just a sort of like mixing paint together. We need a little bit of red, a little bit of green, a little bit of blue, and we can combine that to make a whole bunch of different colors. And that allows us a much wider palette than just the predefined Excel constants like VB red and VB blue. But that's all there is to cover in this lesson. We talked about the font property on a range object. The font property returns an object of its own. We call that font. That font object has a whole bunch of properties on it: bold, italic, which expect booleans. We have underline, which expects a predefined constant. We have size, which expects an integer to represent the size of the font in pixels. We have name, which represents the actual font that we want to use. We can use anything that we have available to us in Excel. We have the color property. The color property actually expects a wide variety of inputs. We can give it a predefined Excel constant. We can give it an RGB function here, which is going to evaluate to some kind of color. You can give it a value for red, green, and blue from 0 to 255. And there's even more properties available on font that we didn't discuss for more complex operations like striking through things, subscripts. Those are all more advanced operations, but I trust that if you understand these concepts, you can dive into the documentation and take a look at some of those additional properties yourself. That's all there is to cover here. I'll see you in the next lesson. In the last lesson, we took a look at the font property on a range object. The font property returns a font object, which allows us to modify the look and feel of the font of a cell. Well, we can also use VBA to modify the background styling of a cell or range, and that's what we're going to explore in this lesson. I'll begin here by defining a procedure called paint with colors. And what I'm going to do here is the same thing as in the last lesson. I'm just going to define a variable to store my range object. So dim r as range, and let's set r equal to some range. This time around, I'm actually going to use the cell syntax just to break things up a bit, keep things exciting. And let's reference something besides cell A1. So let's say we want to target cell 4-3. That's row 4, column 3. So that should be right here. Should be cell C4 right here. Okay, so what can we do with this range object? Well, range objects, in addition to having font properties, have a property called interior. And interior, you can think of that as being the background of the cell or range. So on interior, that's a separate object. We have a whole bunch of properties available here. And we have a similar property to font. We have a color property, and this is where we can actually set the background of a cell. So we have a whole bunch of options available to us here, including all the predefined constants we took a look at in the last lesson. So for example, VB red, VB blue. We actually have an option here of VB magenta. You can take a look at what that looks like, but the syntax here is just referencing the interior object on a range, referencing its color property. Here we're giving it a predefined constant. F5, we can see we've colored that entire background of the cell. All right, so this is not the font. So the font is not going to be affected. It's still the standard black for now. You can see that if I even type a value in here, hello. The font size, the font weight, the font family, none of that is affected. This is strictly the background of the cell, which is called the interior. So we can give it a predefined constant. In addition to VB red, VB blue, VB magenta, we have a couple other options like VB black, VB green, VB yellow, VB cyan. That's another interesting one. Let's take a look at that. You can find a list of these predefined constants if you just Google them. Very quickly, you'll be able to find a short list if you just want to use some of these predefined colors. Now, just like we saw in the last lesson, we can actually use the RGB method, which again stands for red, green, blue. It expects arguments of how much red to put in, how much blue, and how much green. Again, from 0 to 255, 0 being none of that color, 255 being the max. If we want something that's black, by the way, that's going to be 0, 0, 0, none of each. So if we take a look at that, that's a cell that's entirely black. If we do all 255, that should be a cell, if I remember my color theory correctly, that's entirely white. Exactly. So that's kind of the standard, all white. And then we just specify how much of each color we actually want. So if we want to have, let's say, a mix of red, green, and blue at equal amounts, that's what that color is going to look like. Looks like it's kind of a darker gray. There is one other way to add color to a cell that I want to show you. I'm going to have to introduce some advanced concepts here, but you don't have to really worry about them. Just a little bit of syntax to show you all of the colors that we have available to us. So let me go ahead and clear this up. What I actually want to do here is, don't worry about what I'm doing here, but what I'm going to do is create what's called an iterator loop, which means I'm going to go over a whole bunch of values. I'm actually going to go through the values 1 to 56 to show you how this works. Don't worry about the syntax if you haven't seen it so far. We'll discuss it in greater detail throughout the course. Just focus on what I have written here in between this block of that begins with the word for. So what I'm going to do here is I'm actually going to iterate, which means go from the cells from the top to the bottom, and I'm going to target the cell in the first column, column A, and on my interior object, which again belongs in every single range, I'm just going to go through the cells like this: A1, A2, A3, A4. Each one of these is going to represent a specific range object. That's the range object whose interior I'm going to be targeting here. So on the interior object, we saw that we have color. We also have a property called color index. And color index actually accepts a numeric value. It can accept a value from 1 to 56. And these are, again, a list of predefined Excel colors. So some of the most common colors used in Excel, each one of them has a numeric value. So what I'm actually going to do here is go through 56 cells in column A and paint each one of them with a different color. So you can take a look at what these 56 colors are all at once. And then I'm also going to put in each cell the actual number of the column, of the color rather, so you can have a reference to that. So let me just finish up the syntax. This is going to be equal to I, which is the number I'm iterating over. And then the last thing I want to do is actually put the number in the cell. Again, if you haven't seen the syntax, don't worry about it. What I'm just doing here is allowing us to see all of these 56 colors at once instead of having me manually write 56 different color numbers out. Let's take a look at what this looks like. There we go. So what I've done in each cell is I've used a predefined color and I've written the number that that color is. So this red, for example, is color index number 3. If you were to take this syntax and instead of putting I here, you were to put number 3, you would get this red. Number 4 is this green. Number 5 is this blue. All the way down, this is kind of the standard palette, the color index palette as it's called. We have a total of 56 colors, and these are kind of the predefined Excel colors. I'm pretty sure, I wouldn't be completely certain, but I'm pretty sure it constitutes most of the colors that are found here. Definitely all of the standard colors. We can see sort of the standard red and green and blue are the ones that we're seeing down here. All right, so that's another way that we can set the background of a cell. We can use the color index property and give it a numeric value 1 through 56. We can also give it one of those predefined constants. We can also use RGB, which is by far the most flexible and powerful way because, again, if we have 256 combinations for red, green, and blue, we have more than 16 million possible combinations. I think the actual number here is actually 16,777,216. So a whole bunch of options available to us if you want to use RGB and you want to have a really custom aesthetic scheme to your documents. But that's how we set the background. And of course, we can combine the interior property on a range with the font property and the font object. That way we can set the font as well as the background. Just remember that those are two completely separate components. You can sort of think of it as the background is the interior and the foreground, what's in front, is the font. And we can modify each of these completely in VBA. Again, all of programming is just figuring out what object we want to reference, what properties we want to affect, and what values we actually want to give them. It's as simple as that. All right, so we took a look at the range interior property in this lesson. That's all there is to cover here, so I'll see you in the next one. In this lesson, we'll take a look at the column width and row height properties on a range object. And just as the name suggests, these allow us to set the width of a column or the height of a row for any range object in VBA. For this lesson, I'm not going to write a formal procedure since most of our code will just be one-line snippets, so I'm going to stick with the immediate window. And there's actually two different syntax options that are available to us in order to change either the column width or the row height. So let's explore the first one. The first thing I need to do is to target a single cell in the column that I want to change the width for. So let's say I want to target cell A1 because I want to change the width of column A. So I can target any single cell in column A. It can be A1, A2, A5, doesn't really matter. Once I have that range, on my range object, I actually have a property called entire column. This is a bit of an interesting property because the entire column actually selects a brand new range object that represents the entire column that range is found in. So for example, if I just select A1, you can see that my cursor is now going to be selected with this cell. If I change this to entire column, this is still going to be a valid range object. The only difference now is that it's going to select the entire column. And that's exactly what we want to target because we're not changing the width of any one cell, if you think about it. We're changing the width of an entire column that cell belongs to. So once we have the entire column selected as a range object, we can use the column width property on that range. And this just expects a number that represents the width, I believe in pixels, that we want to set. What we can actually do here is take a look, if we right click on any of the column headers and take a look at column width, it's going to tell us what the current value is. So this column is a width of 8.43. So if we want to do something like roughly double it, we can set this to something like 17, and that should double the width of that column, column A. When I execute this, you can see it's been expanded in size. If I want to make it something smaller, it's a matter of changing the number around, and that makes it smaller. Let's check if this actually accepts floating point numbers. Let's say if I do something like 7.5, that works as well. So the number can be anything from a long, which means a whole number, or a floating point number with a decimal point. Okay, so that's our first option for changing the column width. There's another option available to us. On my application object, which sits at the very top of the Excel object model, we have a property called columns right here. And since it's at the very top, we don't actually have to reference application. We can target it directly. What columns allows us to do is to give it an input, for example, a string that represents the column or columns that we want to select. So if I do something like columns, let's do B now, column B. If I execute select, this is a shorthand way that we can select a single column. So we don't have to target a cell and then use the entire column property. We can just use columns to target a specific column like so. And so again, this is returning a brand new range object to us that represents every single thing in that column, column B. We can use the column width property on this. Let's set this to something like 40, give it a nice big width, and there we can see we've expanded the width of the column. If we want to affect more than one column, by the way, all we have to do is use that colon syntax. So if I want to target, let's say, columns B through E, so that's a total of 4 columns, B, C, D, E, I can just target it by writing a colon, starting with the first column, the colon, then the end column. Execute this. This should make all of them equal to 40. If I want to make that a little bit smaller, let's say 10. There we can see we've shrunk them all at the same time. The process for changing the height of a row is very similar. I'm going to show you both options. The first, again, is to select a single cell in that row, then select the entire row. So I'm just going to switch things up right now by using cells instead of range, just to keep things exciting. So let's say I want to change row number 8 right here. So this is going to be row 8. I can target any cell in that row. So let me just click out of here. For example, cells 8-3 is going to select cell number C8. That's in row 8. What I can do once I have a single cell is use an entire row property, very similar to entire column. This is going to return to us a new range object that represents the entire row. So once I have the entire row selected, there's a property called row height instead of column width. Otherwise, it's the exact same. We just give it a number. How tall do we want the height to be? Let's check the default right now. So this right now, if I highlight this, click this, row height, right now it's set to 15. So if I want to set this to something like 45, that should make it 3 times as tall. There we go, the row is now 3 times as tall. And the alternate syntax for this is very similar to how we use columns here. There is a property on application also called rows. For rows, instead of giving it something like a letter, we can give it a number. So if I want to target, let's say, row number 5, I can do row number 5. Once again, this selects the entire row. We can validate this by using the select method. There it is highlighted for us. Once it's selected, I can use the row height property on it, set it to something interesting like 20. There we've expanded the size. It's not really that visible, so let's make it something bigger. Let's do it 50. There we go. That's a much bigger row. If I want to target more than one row at a time, I can still use rows, but this time around I have to give it an actual string. The string is going to follow a very similar syntax where we begin with the starting row and we end with the last row. So if I want to start from row number 2, go down to row number 5, I can just do 2:5. That's going to select the entire range of rows. I can validate that right here with select, and on this I can apply the row height property and set that to something that we want. Let's say we want to make it 75. There we can see we've expanded the height of all those rows 2, 3, 4, 5 to be a height of 75. That's all there is to cover in this lesson. There are two different approaches here that we can use to target an entire column or an entire row to adjust the relative width or height. The first is to select any single cell within that row or column and use either entire column or entire row. That's going to give us a brand new range object. We can then use the column width or row height property on that. The second option is to use the built-in rows or columns properties. Those are available directly on the application object. Those allow us to give inputs of either the letters that represent the columns or the numbers that represent the rows. It automatically selects that entire column or row, so it's kind of a shorthand way of doing it. And then we just use the familiar column width or row height property to accomplish the same effect. That's all there is to cover here. I'll see you in the next lesson. In this lesson, we'll take a look at the autofit method on a range object. The autofit method changes the width of a column so that it captures all of the text within it. Now, this is actually a very popular functionality in Excel's main interface. If you've ever had a cell that has way too much content in it, what you'll notice is that the content will actually escape the boundaries of the cell, but the column width won't be extended. Now, there's two things we can do here. Most people know that we can click and drag this to whatever width we want it to be so that it can capture all the content. But a better approach is just to hover our mouse between columns A and B until we get this black cursor. And if we double click, Excel will automatically expand the column width so that it captures all of the content. So it's going to be as long or as wide as it needs to be so that that content doesn't escape the boundaries. And that's the exact same functionality that the autofit method offers us in VBA. So what I'm going to do here is drag this back so that the content is not perfectly captured within the cell. And in my Visual Basic Editor, I'm going to define a method called expand widths. And it's pretty simple. We're going to use the columns property that we saw in the last lesson. It's just going to be columns. This is a property on the application object. We saw in the last lesson how we can give it a single argument of a string that represents a column. We can actually also give it a numeric argument. I didn't mention that last time around. So if we wanted to target column A, we can either do this or number 1 because that's the first column in line. I'm going to stick with the string of A, and it's as simple as calling the autofit method capital A, capital F, execute this, and the column width will expand to include the entire text. Just to show you again, we're going to drag this back to its smaller width. Let's change this to column 1. Same result, F5, it's going to expand to the width. What if I want to target more than one column? Well, let's go ahead and drag this back, and let me copy and paste this content to B1, C1, D1, and E1. So now all of these cells have content that is kind of stretching past its boundaries. Well, whenever I'm using this syntax, I have to use actually a string representing the column numbers, so A through E. So we're just going to use a colon in between the starting column and the ending column. And what this will do is autofit every single column within that collection that we've given it. So columns A through E will be expanded. Their widths will be expanded to fit the content. F5. There we go. We can see A has been expanded, B has been expanded, and now all of the content fits snugly within those boundaries. So that's the autofit method. This is a functionality that is available to most Excel users. I'm not sure how many people actually know about it, but it's a very, very cool feature because you don't have to click and drag. You can just double click and Excel will take care of that hard work for you. But we have that exact same functionality in the Visual Basic Editor. So if you don't want to use the column width property to guess what the size will be and you automatically want to guarantee that it's going to capture whatever the cell is holding, you can just use the autofit method. In this lesson, we'll take a look at the clear contents, and clear formats methods on a range object. And as the name suggests, all of these methods deal with clearing something from a range. The clear contents method clears a formula and a value from a range, but it doesn't change any of the actual formatting or any of the visual aspects of the range. The clear formats method clears the formatting of the range, but not the actual values or formulas. And finally, the clear method is the big catch-all method. It does everything. It clears the entire object, meaning the values, the formats, the notes, everything. So let's take a look here. I'm going to populate column A with a whole bunch of values. Just let's do 1, 2, 3. And I'm going to color each cell a little bit differently. So let's just put some kind of styling in here. I'm going to use light blue. Cell below, I'll do something like light green. And the cell below, let's do something like light orange. These colors are just random. They don't really matter, but they serve to demonstrate how all of these methods work. A couple other things I want to do. Let's go ahead and bold the number 1 in cell A1. Let's go ahead and italicize number 3 here, just so that we add a little bit of formatting to the content of our cells, all right? Let's take a look at what this does here. I'm going to create a method here, or rather a procedure. I'm going to call it clear stuff. Clear stuff. Let's begin with the clear contents method. So I'm going to target range A1 through A3. I'm going to use clear contents. As the name suggests, clear contents removes the actual cell values, whatever we have written inside them, but it doesn't remove the formats. So when I execute this, you can see 1, 2, and 3 have been removed, but the actual cell backgrounds have stayed in place. That includes not just the actual color of the background, or the interior as it's called, but also things like the border. So if we add a border here, let's just do it right here, and let's add a thick outside border to this cell right here. If I execute this again, you can see that the border is going to remain in these cells. Let's just go ahead and put the values 1, 2, and 3 back into those cells. I'm going to comment out this code so we can do a side-by-side comparison. And the other method that's available to us here, once again, range A1 through A3. The other method is clear formats. Clear formats is the opposite. It clears the formatting of a cell, but not the actual content. So 1, 2, and 3, those numbers will stay in place. But if I execute this, you can see the entire format of the cell has been removed. That includes everything from the bolding and the italicizing, that includes the background, and that includes the border. So anything related to the visual aesthetic or the look of the cell, that's going to be removed by clear formats. So let's go ahead and bring those formats back. You can't actually Control Z after a VBA operation, so I'm going to have to go ahead and just populate these cells with a couple more cell backgrounds. So it doesn't really matter what we choose here, as long as they're all a little bit different. Let's once again make one of these bold. Let's make one of these italic. Let's also add a border to all of them, just so we can validate everything. So we talked about clear contents. That clears the contents of the cell. We talked about clear formats. That clears the actual look and feel of the cell. And of course, we have a method here called just clear. And clear is essentially a combination of these two. It clears everything. So as soon as we execute this, the entire cell will go back to its original shape. It's not going to have a background or a border or any bold or italics or any values. So clear clears everything. You can think of it as the simplest and shortest method, clear for kind of a blanket clear across the entire thing. So when I execute this, we're going to go back to the spreadsheet the way it was. So we started with a blank spreadsheet and we end with a blank spreadsheet. Pretty romantic there. All right. So that's all there's to cover in this lesson. The clear method, the clear contents, and the clear formats method, each one targets a different aspect of the range. Clear contents targets the values or formulas within a cell or range. Clear formats targets the aesthetics of a cell, its look and feel. And clear targets everything, just gets rid of everything possible in that cell. Values, formulas, formats, notes, borders, everything. All right, that's all there's to cover here. I'll see you in the next lesson. In this lesson, we'll take a look at the delete method on a range object, which predictably deletes the cells in a given range. Let's begin by populating a few values here in my Excel spreadsheet. I'm just going to spread them out over a couple columns and a couple rows. So let's just write a couple numbers here, 1, 2, 3, and 4, 5, 6, and let's do 7, 8, 9 right here. And I'm going to be sticking with the immediate window because all of these steps are pretty small and lightweight. All right, let's begin with one way that we can reference our rows and columns, which is using the rows and columns properties. You may recall a syntax like this. We can do something like rows, and we can provide a string here to represent the rows that we want to target. So for example, rows 4 through 5, and I can do it like this, 4:5, the beginning row and the final row in double quotes. This is actually going to give me a range object. I can prove that by calling the select method, and there we have our rows. And what I can do on this range is call the delete method. And this is going to operate exactly like a delete operation works in Excel. So if I were to right-click right here and click delete, what would happen is rows 4 and 5's contents would be deleted, and row number 6 would be shifted up, and that would become row number 4. So we can keep our eyes on the numbers 7, 8, 9, and those should appear in row 4 as soon as I execute this right now. There we go. So they have been shifted upwards. Everything works as expected. We can also perform the exact same logic when it comes to columns. So what I can do here is just add a few more numbers here, 10, 11, 12. Let's say I want to target 2 of these 3 columns. Instead of using rows, I can use columns. Here, I can similarly open my parentheses, provide a string, and feed in my starting column and my ending column. So let's say I want to delete columns B through C. And of course, this doesn't have to be limited to 2 columns. It can be 1 column, 5 columns, whatever you want. You simply put the starting column and then a colon and then the ending column. If it's only 1 column, then it's just going to be the same letter. For example, B colon B would only target that single column B. In this case, I'm going to target columns B and C. That's going to select the entire range of those 2 columns. We can see that highlighted right here. I can call delete. And of course, just like in Excel, when we right-click here and click delete, what's going to happen is column D is going to be shifted to the left. So those 2 values, 9 and 12, should now appear in column B. So when I execute this, we're going to get a predictable result. There we go. Pretty simple. Let me go ahead and clear this code up. And the next thing I want to show you is what happens when we actually call delete on a single cell object. Usually in Excel, we're going to be deleting whole rows or whole columns at a time. And if you simply want to clear a cell, there are convenient clear and clear contents methods that we've talked about a little bit previously. So usually you're not going to be deleting a cell. You're usually going to be deleting an entire column or row. But I did want to show you the syntax if you did want to delete a cell, because there's an additional argument that we have to feed to the delete method. What I'm going to do here is just write out a couple more values here. Let's do 1, 2, 3, and 4, 5, 6, and let's do 7, 8, 9 right here. And let's say I want to target this cell right in the middle, the one that's at C5 that also conveniently has the number 5. So what I'm going to do here is I'm going to target that single cell with my range property. So range C5 in quotes. And I'm going to call delete here, but this time I need to provide it an additional argument, and this is actually going to be an enumeration or a predefined constant. As a reminder, those are those built-in constants that are available in VBA so that VBA can translate our commands. So if I put a space here, unfortunately IntelliSense is not helping me with options, but there is an option available here called XL to left. What that means is that the cells are going to be shifted leftwards. So what I mean by that is if we take a look at this 3x3 grid, what's going to happen is the number to the right, which is number 6, is going to be shifted to the left to fill the gap that was created by the removing of number 5. So let's execute this. And we can see that 6 has moved to the middle. So what's happened is we've deleted this cell, and Excel has shifted this content on the right side to the left. That's what it means when we say to the left. Let me go back and bring this to its original state of having a 5 in the middle and a 6 to the right of it. Let me just click in here, 5 and 6. And the other option that's available to us when we delete instead of XL to left is actually going to be XL up. What that means is whenever we delete a cell, we want it to be replaced by the value that's immediately below it. So we want to take the value below it and move it up. That's why it's called Excel up. So in the previous example, we took this value and moved it here. In this example, we're going to take this value and move it up. So we're going to take 8, and it's going to take the place of the removed 5. So when I execute this, we can see the 5 has been removed, we've deleted it, and that 8 has been moved up to fill its place. So those are 2 common predefined constants, moving things leftwards with XL to left and moving values upwards with XL up. Remember, it's relative to the cell that's going to be actually moved into that position. It's not where you're starting from. We started in that center, but the enumeration here specifies the path for the cell that's going to be taking the place of that. So XL to left means the cell to the right is going to be moved to the left, and XL up means the cell below is going to be moved up. All right, so it's from that position. But that's all there is to cover in this lesson. We talked about the delete method on a range. It deletes the cells and shifts the cells around it. We can call it on rows or columns. That's usually the most conventional use of deletion in Excel. Whenever you want to completely remove a column's contents or a row's contents, it might be more effective to delete that row or column rather than clearing its contents. It's just more safe and immediately removes not just the content and the format, but just the entire row entirely. So that's a very common user case. So it's highly likely that you want to emulate it in VBA. In addition to columns and rows, we also talked about how we can target a single cell range, call the delete method on that as well. In that case, we do want to provide an enumeration. XL to left and XL up are 2 examples that we can use there in order to shift the cells. That's all there is to cover in this lesson, so I'll see you in the next one. In this lesson, we'll take a look at the range copy and range cut methods, and they operate the exact same way as the copy and cut functionality works in the actual Excel interface. So I want to begin here by creating a range of values right here starting in cell A1. It's just going to be a bunch of random values. So let's just do 1, 2, 3, and maybe 4, 5, 6, 7, 8, 9. So let's go ahead and try to copy this range of cells using VBA. I'm going to write a procedure here in my Visual Basic Editor. I'm just going to call it copy and cut cells. And we can actually copy and paste in a single method call. So I'll begin by referencing the range that I want to target, A1 through C3. I'm going to invoke the copy method, and it's actually going to take a single parameter, which we can see right here, and that is destination. And predictably, destination expects a new range object, which is going to represent where it is that I actually want to paste the contents of my original range to. So where do I want to paste cells A1 through C3's copy? So let's say I want to paste it in cell D8 through, in this case, F10. I can write the entire range, so I can do something like this, range D8 through F10, and this will work. We can go ahead and run this macro. When I press F5, we can see that the contents have been copied. Copy, as a reminder, means completely copied, so the original cell range is not removed or cleared. So here we have our copy, and we've targeted a range with the exact same width and height as the original one. But as it turns out, we don't even need to target the entire proper range. We can simply target the top left cell. This is the exact same way that it works in Excel. For example, right here in Excel, if I simply copy this range and press Control-C to copy, we can see that little border appear around it. And if I were to simply click into something like cell D8, just the top left cell, and press Control-V, we can see the paste operation is going to paste the entire original range. And the same logic applies here. So I'm just going to comment this out and copy this code below. And if I simply write here the top left cell, we're going to have the exact same result. We're going to see all of them have been copied. In fact, if we accidentally miscalculate and provide a larger range than is needed, for example, D8 through, I don't know, Z26, in that case, we're still going to get the exact same result. We're just going to copy it directly to that proper range. Let's now go ahead and take a look at the cut method on a range object. I'm just going to go ahead and clear this content and comment out my code right here. Cut is going to work in the exact same way as copy. As a reminder, though, whenever you cut something, it doesn't just paste the original range to its destination, it also removes the original range. So it's kind of like a movement of the data to somewhere else in the worksheet. So I can begin by once again targeting cells A1 through C3, but this time, instead of invoking the copy method, I'm going to invoke the cut method. And as we can see, it has the exact same function signature. That means it takes the exact same parameters. In this case, it's just destination. Destination is going to expect a single range object. And again, destination here, we're simply writing out the parameter name, but we don't have to do that. So we can go ahead and paste this, let's say somewhere like B13. Once again, when we provide this range, we can just provide the top left cell. And when I execute this, we're going to take the cells in A1 through C3 and cut them to right here in cells B13. So when I execute this, see what's going to go on. Looks like it's a little bit of a pause. There we go. So here is my 3x3 original range of values, and we can see it's also been removed from its original position. So it's been cut and moved rather than copied and moved. That's all there is to cover in this lesson. We talked about the copy and cut methods on the range object. They both take a parameter called destination. Destination expects a range object where you clarify where you'd like that data to be pasted to. If it's copy, it will be copied and the original data will not be replaced. And if you cut, it will paste, but it will also remove the original range that you targeted. That's all there is to cover here, so I'll see you in the next lesson. In this lesson, we'll take a look at the paste special method on a range object. Paste special allows us to paste in a special manner, much like we can in the main Excel interface. For example, if I have a cell here with the value number 1, and I go ahead and copy it with Control-C, whenever I right-click here and I look to paste, there are actually more options available than simply copying over the value. We can copy over formatting, we can copy over validations, we can copy over column widths, a lot of special cases like that that make the paste a little bit more precise or special. And we're going to take a look at that in this lesson. Let's begin by simply using the paste special method. So this is going to be an alternate syntax to the copy method that we saw in the previous lesson. I'm just going to keep this value here in cell A3. And I'm going to write a new procedure here called copy and paste range. Now we know in the last lesson that on a range object such as A3, we do have a method called copy, and we do have a destination parameter there that we can use to specify where we want to paste it. But that's not necessarily the only approach that we have. We can actually call copy here without giving it a destination parameter, and what that's going to do is simply copy it to our clipboard, much like we would do if we pressed Control-C on our keyboard. That doesn't mean we're actually pasting it anywhere, we're just holding it in memory. Once we have this copied, what we can do is target a brand new range where we want to paste. For example, let's target cell C3. and then we can use the paste special method on the range that we actually want to paste into. And by default, this is going to be a standard paste. So when I execute this, we're going to get a value of 1, and in this case that works just fine. But of course, paste special shines when we have to perform some kind of special operation. A really great example is pasting values. Many times, one of the most common operations in Excel is whenever we're copying a cell that has a formula, we don't actually want to copy over the formula, we just want to copy over the final calculation or the final value. Let me give you an example here. If I have two values here in column A, let's say 3 and 5, and right here below I do a basic sum function, and I add the two of them up. By default, if I click into here, we're going to see the formula itself, sum A1 equals A2. So if I copy this with Control-C and paste it, let's say right here with Control-V, we're actually going to get 0 because what Excel is going to do is copy over the exact formula itself, sum, and then move the range references over respectively. So if we have A1 through A2, it's going to look for the sum of C1 through C2, which of course are blank cells, which results in 0. So what we wanted to do here, of course, is not simply to paste the formula, we wanted to paste the final calculation, which was 8, without actually deleting it here. So of course, in the main Excel window, what we can do is right-click here and click this special 1, 2, 3 icon, which means just paste the values. And when we paste the values, we're just going to get 8. We can in fact see the difference because right here in the Excel formula bar, we have the number 8, but if I click into this cell, we have the full formula written out. We can emulate this exact same functionality right here. In order to do that, all I need to do when I invoke paste special is to give it a special enumeration. As a reminder, an enumeration is just a collection of predefined constants that allow Excel to modify how it performs an operation. And what we have here is all of the enumerations that represent the different ways that we can paste. So if I just take a look at some of them here, you can see that we can paste just the column widths, we can paste the comments in a cell, we can paste the format of a cell, things like its font style, its border style, etc. All of these are different enumerations that you can dive into in the official VBA documentation. The one that I actually want here is called paste values. And notice as well, by the way, that all of these begin with XL. So if I type XL paste values, that's the one I want. That's the exact same thing as pasting values in the Excel interface. This is going to copy over the actual calculation in the cell rather than the formula that was used to calculate it. So this is emulating the exact same thing we just saw. Let me go ahead here and just clear this so we can see this in action. The cell is now blank. When I execute this with F5, we're going to get a value of 8, and when I click into here, we can see it is actually 8. It's not the exact same formula. So everything is exactly as it is on the main Excel interface. And again, this is not simply limiting to pasting values. We can also paste formats, conditions, all that kind of fun stuff. Just depends on what it is that you want to do, and at that point, you have to find the right enumeration to accomplish that. That's all there is to cover in this lesson. We talked about the paste special method on a range object. It works without any kind of parameters. If it does, it's just going to be a standard default paste, the same way that Control-V works, the same way as providing a destination parameter to the copy method works, but really paste special shines when we give it a parameter to work with. In fact, that parameter is called paste, and that specifies how we're going to paste it. That paste parameter expects an enumeration, and that enumeration will clarify exactly how it's going to perform the paste process. That's all there is to cover here, so I'll see you in the next lesson. In this lesson, I want to introduce the parent property, which is actually available on all major objects in the Excel object model except for application. What's really cool about the parent property is that we can use it to traverse the Excel object model upwards instead of downwards. The parent property on a given object will give us that object's parent, or the thing immediately above it, the parent object that is containing it or enclosing that object as a property. Let's take a look here in the immediate window. What I want to do here is actually start at the bottom with range and use the parent property to navigate all the way up to the application object at the top of the hierarchy, which again represents the entire Excel application itself. So I'm going to begin with a sample range like range A1. And on a range object, I have a parent property. This is actually going to give me the parent of a range, the thing above it that's enclosing it, which is, of course, a worksheet object. Now, by itself, this syntax is not going to work. I can prove that by pressing enter here. We're going to get this error, runtime error 438, object doesn't support this property or method. All this essentially means is we are properly referencing an actual worksheet, but we can't simply output the value of a worksheet because that's a complex object. VBA has no clue what to actually show to the user. We need to actually choose a property that we're going to output here with the question mark. So there are two ways that I can prove that this is an actual worksheet. The first is by wrapping this entire expression expression in my type name method. Remember that that's going to give me back a string that represents the type of object that this is. So I'm starting in a range, I'm getting that range as parent, and the type of that object is a worksheet. And the alternative thing that I can do here is once I have the parent of range A1, what I can actually do is actually choose a property on that worksheet. The simplest one, of course, is name. And we're going to get sheet 1. That's exactly the sheet that I'm currently on. Perfect. So let's continue this process upwards. What I can do is this. I can do range A1 parent. This is giving me a worksheet object. I can tack on a parent property right here as well. The reason I can do that is because every single object in the Excel object model, with the exception of application, has a parent. So once again, I can wrap this in a type name, and we're now going to get the parent of a worksheet, which of course is the workbook. A workbook is containing a specific worksheet, right? So we can also call the name property on this workbook. Remember that a workbook has a name property. The only difference there is that that property is not overwritable like it is for a worksheet. So when I execute this, we can see that this is the name of my workbook, my entire Excel file. Notice here I kind of glossed over this a little bit, but we're not getting the collection object. So the parent of worksheet is not going to be worksheets, which is the collection. Rather, it's going to be the workbook. It's kind of the literal enclosure around it. And if you think about it, a workbook is containing a worksheet. Worksheets is kind of just the intermediary middleman. We do have to reference it when we're traversing down the Excel object model, but the thing that's actually enclosing a worksheet is a workbook. We can continue this process by going further up. So right here, I'm once again starting at range A1. The parent property is going to give me the parent of a range, which is a worksheet. The parent property of that is going to give me the parent of a worksheet, which is a workbook. And the parent of a workbook, of course, is going to be the entire Excel application. What I can do one more time is to wrap this in a type name rather, and close my parentheses here, and we're going to get the application. And of course, application also has a name property. That's going to bring us to essentially the end of all the content here. If I remove this, we now have the application object referenced. And what I can do is get the name property, and there we have it, Microsoft Excel. That's all there is to cover in this lesson. So much of this course has been focused on traversing the Excel object model downwards that I thought it'd be interesting to kind of summarize and finalize everything by showing you how we can proceed upwards. So we can begin with a range and use the parent property, and that's just not available only on a range. That's available on workbooks, worksheets, almost every object in the Excel object model, all the way up to application, and we can continue this nested process to continue climbing up this ladder back up to the very top where we finally reach application. So good summary of everything that we've learned so far. That's all there is to cover here, so I'll see you in the next lesson.